So I've posted your practice exam online. So the practice exam for the first exam, it's a good facsimile of the actual exam. So and today we're gonna just learn the rest of the stuff that's gonna go into the exam, which is about indefinite loops. And first we're gonna learn a bit about yes. It's going to be it's going to be next week in your lab. So not this Friday, but next Friday. And you'll have the full lab period, which is 2 hours to work on it. Well, an hour and 50 minutes. So, all right. So we're going to go over some program logic and indefinite loops, which is specifically the fence posting problem and while loops. So let's start by writing some. Let's start by working on a problem that looks simple, but actually is a bit troublesome. Let's write a method called print numbers that prints each number from 1 to a maximum, and that number is separated by commas. So, for example, if we called print numbers 5, it will print 1, 2, 3, 4, 5, separated with commas, but no a comma after the 5. So let's go ahead and go to Eclipse, open it up. And this looks like it should be a fairly easy problem to take care of. There's no real, there's nothing really too exciting going on. So let's go ahead. Intro, okay. Chapter 5, fence post. Okay. So let's create our new method. Public static void print numbers 5. So print numbers int n. So it's going to print all the numbers from 1 to n separated by commas, which, we'll start by writing a for loop, and go, okay, for int I is equal to, since we're going to start at, since the first number we want starts at 1, we're going to start at 1, and since we want to go up to and include the number n, we're going to say I is less than or equal to n, and then go up 1 by 1. Right? This is going to go through all the numbers from n. And then we'll do system.out.println I plus a comma and then a space. Oh, and we don't want it to be print line. We want it to be print because we want it all to be on the same line. And then at the end, we'll do a system.out.println to make sure that's all on the proper lines. So system.out.println. Okay, so now call it print numbers 5. Oh, that's close. But what's wrong? Yeah, comma. I heard somebody mutter it in the back. You've got a comma. I've got a comma after 5. I would like 1, 2, 3, 4, 5. No comma. No space after that. Right? So I'm in a bit of a pickle here. Right? So if I do it, so that's what I wrote over there. Oh, and if I try to do, okay, you might have the idea, what if I move the comma beforehand? Okay. Why don't I just try moving this beforehand? So, comma, space, then plus I, and remove this other comma over here. Well, okay, so the 5's right, but now I've got a leading comma. So that's a bit of a problem, right? And you're realizing, this is going to be a bit harder. Not too hard, but a bit harder than I thought. And the idea is that there's a fence post analogy here, which is that basically, if you're laying down a fence, right, you have fence posts, right? Basically, the pieces of wood that hold up the fence, or aluminum, or whatever they are. Okay, so you've got your fence posts, and then you've got the wire or the walls of the fence post. And the idea here is that with a fence with these fence posts, you need, you'll have one more post than you do pieces of wire, right? So the idea here is that basically if we put down a post and then we put down a wire, and then put down a post and then put down a wire, then put down a post over here and then put down some more wire, and so on and so forth, you're going to end up with one more piece of wire than you need. Right? That's kind of the analogy we're working with here. So instead we need to actually kind of cheat a bit and do some of the work outside of the loop. The idea here is that so to go back to our actual example, we need one more. So let's look. We have 5 numbers we need to print, but we have 4 commas. But we have 4 commas that we only want to print. We only want to print 4. So if we consider these to be like our fence post analogy, each number is a fence post, and each comma and space is like a line of wire connecting those posts. So we need to put down one less of those. And the only way to do that is, since this for loop creates an even number of numbers, so it creates the exact same number of numbers and commas, we got to print maybe a number earlier or possibly later. So there's a couple of solutions to this. One they have is that we can start. Okay, so they do both. So I'll go ahead and do that. The idea is that we're going to put either the first number or the last number down outside of the loop. Okay, so here, what I'll do, one solution is to do this: system.out.print line. Sorry, to .print. I'm going to print out 1. Okay, by itself. And then for every other number from 2 to n minus 1, what I'll do is I'll print out my comma, my fence post, and then I'll print down my wire, and then I'll put down my fence post over here. So here, if I do it like this, I get 1, 2, 3, 4, 5, which is the answer I'd like. So here I printed the number first, and then I printed out an equal number of numbers and commas after that. That makes sense? So that way I was able to print out the extra number that I needed. Typically, this is the way you typically think. Typically, you go through, okay, let me go through all this stuff first, and then I'll treat the last item as the exception to the rule. So instead, what we'll often do is that you'll say something along the lines of maybe 1 up to, but we're not going to include n, right? Because it's easier to think in this way usually. So I to I plus. And let's just pause to see what we have here, right? This will print out 1, 2, 3, 4, but it doesn't print out the nth number, right? So now that we're done with that, we can do system.out. Over down here, actually, I can just use this. Print line n. So I print out all the numbers except for the last one, and then I put the last one down by itself because I don't need a comma after it. The reason I print it out by itself again is because if it was inside the loop, it'd be printing out a comma and then a space after it. Does that make sense to everybody? So the idea here is that this is basically where sometimes you just need to print out, if you're printing out n things, but you have n minus 1 things between each of those things you're printing out, you sometimes need to handle the first item or the last item specially. So this is what we call the fence posting problem. So let's see. So let's go ahead and modify our problems. So this problem says, modify your print numbers to a new method called print primes that prints all prime numbers up to a maximum. Okay. So let's go ahead and review what a prime number is. Anybody remember? And who remembers the definition of a prime number? Come on, surely somebody. Yes. Only divisible by itself in 1. So we can test and see if a number. So if a number is divisible by a number that's not divided. So if the number is divisible by another number that isn't itself or 1, it's not prime. So that's what we'll do. Right? A prime number is divisible by itself and 1. Right? So 2 is prime because it can only be divided by itself and 1. 3 is prime because it's only divisible by itself and 1. 10 is not prime because it can be divided by 5 and 2 or 1. Sorry, 5 and 2, as well as 1 in itself. So we can create a test. Basically, if we'll check all the numbers between itself and another, and what we're going to do is that we're going to check all the numbers besides itself and 1, and if it's divisible by any of those numbers, well, then it's not a prime number. Make sense? So for 10, for going back to the example of 10, I'll first check to see if it's divisible by 2. Well, it's divisible by 2, so it can't be a prime number. Okay, what about 9? Well, I'll check, is 9 divisible by 2? No, it's not. Well, is it divisible by 3? 9 is divisible by 3, so it's not a prime number. What about 7? The way 7 will work is that I'll check, is it divisible by 2? No. It's divisible by 3? No. 4? No. 5? No. 6? No. Okay, so all the numbers between 1 and 7 we checked, so it can't be divisible. Now, there's a way to optimize this, but I'm not going to get into that. But let's see, with is prime, int n. So, okay, so we're going to assume that, so with Booleans, I like to assume if the number is true over here. So return true by default. Otherwise, we're going to put it through a loop like this. So for int I is equal to 2. Why 2? Because we're going through all the numbers up to but not including n. And we're not going to include 1 because everybody's divisible by 1. I is less than n, I plus plus. So how do I check if a number, if it's divisible by a number? Modulo. So if n mod I equals 0. So in other words, if I divide it by I and the remainder is 0, then that means it was cleanly divisible. So that means that I would want to return false over here. So this is a very interesting paradigm I've got over here. Essentially what I'm doing is that I'm checking each number. As soon as I find a number, I do return false. Now, once you hit a return statement like this, basically the program stops. Once you hit a return statement, the method just stops. So, for example, system.out.println always return true. Return true. It's actually going to give me an error now saying that the code beneath it is unreachable. Because what's going to happen? We'll always return true. It returns true. And so it just stops. It doesn't bother checking any of the other code. Likewise, since we're going through this for loop over here, int I is equal to 2, I is less than n. As soon as we find one number that our possible prime number can be divisible by, that it is divisible by, we can just stop, right? We don't have to check the rest of the numbers. We don't have to have a Boolean up here saying Boolean failed is equal. Sorry, Boolean. We don't have to have something like this. Boolean prime is equal to true. Then do if it's divisible by something, set prime equal to false, and then return prime over here. We don't need to do that. Now it's going to still give us the same answer, but the idea over here is that if we have it set up like this, then it's going to continue checking numbers even after we've determined it's false. Once we've determined that it's a prime number, it's no longer a prime number, no other information we collect is going to change whether it's not it's a prime number. So we can just stop the program immediately by putting in a return false. Does that make sense to everybody? Oh, and I say the program, but I really mean the method. So let's go ahead and test this out. So system.out.println is prime 5. So this will return true. What about for 4? True. So it's a false, right? Because 4 isn't prime. 121. It's not a prime number. 113 is a prime number. So we can see, so this works out basically figuring out whether or not something's a prime number. So now we can modify print numbers and write a new method called maybe print primes. So we're going to do that. So we're going to copy this and change it. And here we're going to print all the prime numbers from 1 to n. Print primes. Okay. So first off, we need to do this like right now. Print primes does the exact same thing as print numbers, right? But instead, what we wanted to do is only print out numbers if they're prime. So now we'll just ask ourselves, if I is prime I. So if is prime returns true for I, we'll go ahead and print it out. So now I want to print out all the prime numbers from 1 to 5. Well, first I have to actually call that function, right? Print primes. 1, 2, 3, 5. Okay, that seems to work. Spoiler, I'm not done yet, actually, because I've got a bit of a problem. So let's print out all the prime numbers from 1 to 10. 1, 2, 3, 5, 7, 10. 10's not a prime number. Why is it printing out 10? Because the computer's an evil genie who does exactly what I tell it to do. I told it to check all the numbers from 1 up to, but not including 10, right? But not including n over here. Then I ask if each of those numbers are prime, and I only print it out if it is prime. And then I print a comma and a space after them because fence posting. And then, oh, I forgot to check the last thing over here, right? Uh-oh. Suddenly this problem seems a bit harder. Because, okay, obviously I can just check if this is prime. Right? Now we've got our dangling comma problem again, right? We thought we solved that. What's the issue? Well, the issue is that basically that each prime number prints out a comma after it. And then we checked if the last number is prime, right, to print it out, but if we don't print anything out, there's just going to be this dangling comma in space over here. So, and then if you think about the logic of like trying to figure out whether to print a comma or not based on what's a future output it might be, that's a bit tricky to do. So our solution should probably be, since we're always going to print out 1, right, is maybe we'll print out 1 and then we'll do the for loop the other way around, right? Sometimes you have to think about doing it the other way around. So here, the first way is, so here what we're going to do is that we're going to modify this one. So first we'll do system.out.print. We're going to print 1, right? And then we're going to flip it around. We're going to check all the numbers from 2 up to and including the last number. And we're going to remove this little nonsense back here, right? So if the number is prime, instead we'll print out the number and then followed by a comma. Okay, so we've got 1, and then we've got 2, comma, 3, comma, 5, comma, 7. So it's not printing out 10 anymore, but the comma should go the other way, right? We have an equal number of, we have the 1 hanging out by itself, and then each of these things has their own commas. So obviously what we need to do, right, this was the first way I showed you how to solve the fence posting problem. Let's move that in front. And now this works, right? See how sometimes the solution for the fence posting problem is to put your fence post down first, then do the rest of the things. Other times you want to put it down last because that's more convenient. All right, so now let's go ahead and just see how this works. All the primes from maybe 1,000 or something. Well, that's cool, right? That's a pretty nice. So that's a pretty nice problem over there. So here's where so let's see what their solution was. If it's greater than 2, greater than or equal to 2, they print out 2. Oh, right, because technically 2 is not a prime. Technically 1's not a prime number, so we should print out 1. So let's go ahead and fix that. And 2 and 3. There we go. All right. So we've been messing around basically with for loops since the very beginning, right? So basically that's one of the things I like about this book. Basically making sure that you get exposed to for loops as soon as possible, so you can get comfortable with them, which means you also get comfortable with Boolean statements and assignment and updating operations. But sometimes the for loop isn't the right tool for the job. The for loop is what we call a definite loop, meaning we know that when we look at a for loop, we've got a pretty good idea of how many times it's going to run. For this one, it's going to run 3. Its i's values are going to be 3 up to and include n. So it's going to run 3 through n. We know that this for loop over here is going to run 1. Its values are going to be 1 through n, so it's going to run a total of n minus 1 times. Right? We can kind of look at for loops and figure out how many times they're going to run. And for loops are good for telling basically if we want to run a program a certain number of times. But sometimes when we're asking users to take in input, and then basically ask then like, so maybe they take an input and then they type in stop to tell us whether or not they want to stop, right? A program like that, that will need something called a while loop instead, because we don't know how many times they're going to input something, right? If we're taking in just a bunch of user input, we don't know how long it's going to last. So what a while loop is for is when we don't know how long the loop needs to go on. It's an indefinite loop. Now, you don't necessarily need a while loop in the language with the way the for loops that work. You can convert any for loop into a while loop and any while loop into a for loop. But a while loop sometimes makes the code cleaner and easier to understand. Most of the time you'll write a for loop. But a lot of times when you don't know how long the loop is going to run, you want a while loop. Right? So definite loop executes the number of times. The for loop use something like print hello 10 times. Find all the prime numbers up to an integer n, which we just did. Print each odd number between 5 and 127. Okay? Indefinite loop. This means we don't know how often we need to run the loop body. So, in other words, like asking the user to input stuff until they type in something that's not negative. Print out random numbers until we get a prime number. Repeat until the user types in Q for quit. So a while loop looks something like this. And we're going to use something that looks like a while loop. The first thing to do with the while loop is basically to write a while loop that looks like a for loop. So repeatedly execute. So basically it's going to look a heck of a lot like a if statement. While test is true, keep doing this. As opposed to if statements go, okay, if the test is true, run this once. A while loop goes, while this is true, keep doing this, right? And it'll check at the top of the while loop and ask if you want to basically ask to keep doing it. Does that make sense? An if statement, a while loop is kind of like an if statement, only it can run basically as many times so long as the test is true. So here's your flowchart. Is the test true? Yes. Execute. Is the test true? Yes. Execute. Their example is, let's set int num equal to 1. While the number is less than 200, print out the number and a space, and then multiply the number by 2 and store it in num. So they update it by multiplying it by 2. So here, this one will print out 1, 2, 4, 8, 16, 32, 64, 128. Then it gets doubled to 256, and then it's no longer true, so it doesn't print it out. So while int I is equal to 1, I'll go with equal to 0, while I is less than 10. I++. System.out.println I. Now this while loop that I just wrote is actually very similar to a for loop. This will print out 0 through 9, right? I starts at 0, while I is less than 0, print out the number, and then increment I. This looks a heck of a lot like a for loop over here, this one I particularly run, right? It's identical to me writing this. Int I is equal to 0. I is less than 10. I++. System.out.println I. And we see that basically we have our initialization statement over here. So we have our initialization over here and our initialization over here. We have our condition over here, and we add our condition over here. And then we have our update statement at the end, and we have our update statement over here. So you can translate a lot of while loops into for loops, and a lot of for loops into while loops. But sometimes it's cleaner to write a while loop, so we'll get into those examples. Right now it was easier to just start out by showing you something that was familiar. So let's look at an example of this one. Finds the first factor of 91 other than 1. So the first thing that divides it. So while n divided by factor is not equal to 0, increase the factor. System.out.println, the first factor is factor. So first we check, is 91 divisible by 2? No, it's not, so we keep going. So it goes up, and is 91 divisible by 3? No, it's not, so we keep growing. Is 91 divisible by 4? It's not, so we keep going. It's divisible by 5? It's not, so we keep going. What about by 6? And then it checks, is n 91 mod 7, is that equal to something other than 0? Well, 91 mod 7 is actually equal to 0. 91 is divisible by 7. So then it stops. And so we print out factor. What's useful about this is that basically this runs because this while here is good because we don't know how long this is going to run for, right? We want to stop it as soon as we've hit the first factor. We don't know how long it's going to take to hit that first factor. So, so here's a better idea. Let's write a program where we ask the user for numbers until the user types in 0, and then it outputs the sum of all the numbers, okay? Okay, so ask for sum. So system.out.println, please enter numbers enter 0 to stop. Okay, so there's our instructions to the user. Let's see. We'll need a scanner KB to scanner keyboard is equal to a new scanner. So we're going to create a new scanner object to read from system.in so we can read the user's input. We're going to need an int sum to go through this, right? And here the appropriate loop is to write a for loop, right? What we're going to do is that we're going to have some int input is equal to, let's say, some value. Let's see, sum is equal to 0. Is equal to, let's just put 1 there for right now. And so while input is not equal to 0, we'll run the following statement. Please enter numbers, enter 0 to stop. So input is equal to scanner.next, sorry, not scanner, but kb.nextInt. So we grab the input, and then we're going to go ahead and add that input to the sum plus equals input. Okay. I like this problem, even though it's pretty simple. There's a lot of depth to it when we start changing it around. Because there's actually a lot of ways that that this might go wrong. So first, we ask the user if the sum is not equal to, if the input is not equal to 0, and we have to create an input variable over here to have an input. Please enter numbers. Enter 0 to stop. So we get the next input and we add it to the sum. So here. And the while loop is appropriate here because we don't know how many times I'm going to enter stuff. So 4, 3, 2, 3, 1, 0. That's 10, right? Once I hit 0, it said the input was 0. Add 0 to the sum, so that didn't affect it. And then print out the sum. Let's see what they did. So what's wrong with their solution? They said. Enter 0 to quit. That looks a lot like what I have. Let's see. If I run 0, it stops just fine. Let's see. What is wrong with the solution? Anybody? Scanner system.in, the sum is equal to 0. Values that. So while our input is not equal to 0, print it out, grab from the next user, sum is equal to sum plus number. Doesn't seem like there's anything wrong. Let's go ahead and change our value to use a sentinel value of -1. Okay. So now what we want to use is -1 right over here. Okay. So we'll change our input to 0 here. So now let's run it. Enter -1 to stop. 7, 8, -1 to stop. Well, 7 plus 8 is not 14, it's 15. What just happened there? Yes? It subtracted 1. Why? Because I entered -1, and then it added it in to the sum. So what's wrong here, what actually was wrong was kind of a conceptual thing. There was nothing right that was too wrong with the previous one. What was wrong, though, was something conceptual, which is that once I grabbed the input, I immediately added it to the sum no matter what it was. Now, that didn't matter for the previous problem because 0 was 0, and it doesn't do anything. But what if I'm like trying to do something like compute the average? You'll see that that might be a problem in a bit. Right? So our code uses a pattern like this. Sum is equal to 0. While the input is not the sentinel, ask for the input, get the input, add it to the sum. On the last step of it, sentinel -1 is added to the sum because we prompt for input, we read a -1, and then we added a -1 to our sum. So this is a fence post problem where basically we're reading n numbers, but we only want the n-1 of them that occur first, right? We don't care about that last number, right? That last number is something else. So a solution here is that we can do one read outside the while loop, okay? And then, so long as it's not the sentinel, we'll basically just change it up a bit. It's called a loop and a half because we're kind of doing half of it, half of the statement outside of the loop. So here, we'll start by asking the user like this. Please enter numbers. Enter -1 to stop. int input is equal to this. And now while the input is not equal to -1, we'll flip this around. We will add what they put into the input. So long as what they put in is not -1, we'll add it to the input. We'll ask them to print out numbers, and then we'll ask them to give me a new number. Now, this is actually often the correct way to do while loops when we're asking for user input. So 100 and then -1, it prints out 100 this time, right? Now, why? Because I printed out 100. So I asked them to enter a number. They input 100. 100 is not -1, so we add it to our sum. Then we asked them to read another number. I put in -1. Well, that was -1, so we stop and we print out the sum. Does that make sense to everybody? So everybody recognized the original problem was that basically that we were adding, is that, again, the program was literally doing what we were telling it to do. And by the fact that basically we needed to read 2 numbers, but we only needed to add 1 of them, right? We're going to read n numbers, but we're going to add n-1 numbers. So I made sure that the loop did an equal number of adds and reads, as opposed to, and then did the extra reading outside of it. You can't do the extra read out because you don't know when it's going to end, right? You don't know when the user's going to, you can't check the future and say, okay, when the user puts in the number before they enter the negative number. Okay, so that's what they had, which you see is very similar to what I had. Sentinel as a constant, right? So let's go ahead and talk about constants for a second, because I think I did not go over that, but they're useful. Sometimes it's useful to basically have one number that you can easily change somewhere, right? And then, so basically here I said, please enter numbers. Enter -1 to stop, right? And when I changed it from 0 to -1, I had to go and change it in 3 places, right? That makes sense? I had to change this in 3 places over here to fix the code. But say instead of entering -1, I really just want them to enter 0, right? Because maybe I do want them to add, to sum up all numbers, including negative numbers, which would include -1. So what I'll use is something called a constant. So constants, you declare them outside of main. And you write them like this. Public, static, final, and then the type. Let's see if they bothered including the public or no. Yep, public, static, final, and then the type. So public, final, static, int, sentinel equals -1. And the idea here is that this is what we call, so notice that there's a couple things happened here. First, notice that basically it became bolded and diagonal. So as soon as I added the final, it became bolded. My ID decided to bold it. Final is a very nice, it's a word that basically means unchangeable. You cannot change sentinel. So first off, if I didn't have final, let's just go over what that does. This makes it a variable that can be accessed anywhere. So I could be here in main and go system.out.println sentinel, and it would print out -1. I could also use it over here, public static void foo system.out.println sentinel. And I've got this constant value out here. I've got a variable basically that's global along all the methods, right? You can see basically how every method, it's outside of them. It exists outside the methods, right? So any method can use it. Does that make sense? Right? Normally variables, they live for as long as the method they're in, right? All the variables inside main, they go away after main is done. All the variables you would create inside of foo, right? Int x is equal to 5. I can't use 5 outside of here. So I can't use x outside of here, because even though I created it in foo, it goes away at the end of foo, right? It exists inside foo. That makes sense to everybody? Okay. Here, though, sentinel's special. Because it exists outside the methods, I can access it outside the methods. And the reason it has static is, as we'll learn later, since all these methods have static, if we want to access it using these static methods we're creating, it also has to be static. Okay? What does final mean? Well, as I mentioned, final means it's unchanging. And this is extremely useful for constants because we want them to remain constant. Right? Suppose we had some most common example of this is public static final double pi is equal to 3.14159, right? Or something like that. Okay? Now, if I'm in a program that's calculating how circles work or something, I don't want somebody to go in and say pi is equal to 3.0, right? So basically, final variables mean that as soon as they're set, you can't change them while the program in any of the methods or while the program's running. See, it says the final field pi cannot be assigned, right? And this is useful because remember, the math class, it has a .pi in it, and if I were to be if it wasn't final, I'd be able to make a statement like this. I'd be able to change a different class's value to pi. A lot of times when you write your code and you share it with other people, there's like parts you don't want them to change. So final means that basically you can't change it without going into my code and actually editing it. So sentinel means it can't be changed, but the usefulness of this is of having this variable as a sentinel is now I can go and write something like this. Please enter sentinel to stop. So now I will copy paste this. Boom. And then while not equal to sentinel. So now it says, please enter numbers, enter -1 to stop, 10, 20, -1, it stopped, right? Now what if I want to make the sentinel value 0? Well, I don't have to change it everywhere, I just have to change it here. So now if I run it, it says, please enter numbers, please enter 0 to stop, -1, -1, -1, 9, 0. So that way now I can add the -1s to the sum. So having a sentinel value there makes it so that if I want to change my program or a parameter in my program that's used throughout the entire program, I can quickly do it and it changes it throughout the entire program. So that's pretty nice. And that's pretty much what you need for while loops. Now the lab that you're going to get this week, you're going to get 2 of them. Okay? And for once, you shouldn't have to write a single for loop for any of these. Okay? It's going to be 2 assignments, basically both worth 50%. The first one, you're not even going to probably write a loop. That one is purely if statements. And I actually consider it the harder of the one because it's not the syntax that's going to be the problem. It's your best bet is actually using some pencil and paper to think this one out. Don't jump into my date program without basically thinking about what you do first. Don't immediately start typing. Think about how to set it up first. And you'll see why once it's posted. The other program we're going to write is going to be a string Latin program. A pig Latin program, where basically you ask the users to enter words, and they'll convert the words to pig Latin. And if you don't know the rules for pig Latin, we're using a simplified rule set for converting stuff to pig Latin. Basically, they enter a word, it prints it out that word converted to pig Latin for you. And then as soon as you type in the word done, it stops. So let's write one more kind of thing. let's go ahead and write a program maybe called, just kind of an example of how that might work, shout. So this is a program where we're going to make it, where they enter a word and we'll shout at the user. So system.out.println, enter a word, and I will shout it at you. Done to quit. Or let's go ahead and do exit to quit. Right, so as soon as they type in exit, we're not going to print out exit, right? Okay, so first thing we need to do is we need to read strings from the user. So we'll need a string input. Right, and again, we're dealing with the same fence posting problem, because as soon as they hit exit, we don't want them to print out exit, right? We don't want to shout exit at them and then quit. We just want to stop it. So we'll need a string input, and we'll need a scanner. KB is equal to new scanner system.in. String input is equal to, and we want to do this over down here. Next line. Okay. And what we'll do is that basically we will, so while, now your first instinct is like, okay, so we want to quit while it's not, we want to quit if the input is exit. So you go, if input is not equal to exit. Now this might be your first instinct as to what to do, right? All right. So we'll go back to that later. But the idea, so we'll go ahead and write that. So while the input is not equal to exit, if they put in something that wasn't equal to exit, let's go ahead and shout that at the user. System.out.println. How should we shout it? We'll go ahead and we will take their input, put it to all caps, right, to uppercase, right, plus 3 exclamation points to make sure that they really get the picture, right? And then we will, you know, I don't think I need to, I'm actually not going to repeat the directions. Our users are smart. They'll figure it out, right? So we'll just, and then we'll read the next line of input, right? So let's go ahead and run this. Enter a word and I will shout it at you. Hello. So it prints out hello, but now it's shouted at me. World. World. This is a library. Please keep it down. And it shouts, this is a library. Please keep it down, right? So now I'll go ahead and type exit. Right? So, I mean, it's not working. Why is it not working? I said, while the input is not equal to exit. Does anybody remember from one of the lecture videos that I put up? So this is because this is something I mentioned in one of the videos you needed to watch. I said what I mentioned is that basically if you do something like this, right, that let's go ahead and debug. System.out.println input. Then we'll print out plus space exit. So input versus exit plus space input double equals exit. So what we're doing is that basically we're going to print out the word we put in, then versus exit. Actually, we don't need a versus here. We'll print out the word we put in, then we'll print out exit, so we can compare our input to that, and then we'll print out input double equals exit, right? In fact, let's go ahead and just put this up here so that it runs the exact number of times. Sorry. Cut this. Plus, and now we'll put it over here. That way. Okay, so now we can check all of our inputs. Okay. Enter a word and I will shout it at you. Hello. Just printed out false. Interesting. Okay. That didn't work like I thought it would. Input is not equal to exit. System out print line. Input to uppercase plus exclamation points. And it just prints out false. Why is it just printing out false? Isn't that weird? Any ideas as to why it was just printing out false? As soon as I put in, anyone? Yes. Well, I mean, not why isn't it quitting, but why is this not printing out anything else? Oh, input is being set equal to false? Well, input is not equal to false. That's what we're doing over here. So we aren't setting input equal to... Where would input be set equal to false? Parentheses over... Ah, that's right. Because we're comparing... So basically, remember, the double equals, it evaluates left to right. So we were doing input plus uppercase plus this. So we were turning this all into a string, right? And then comparing that entire string to double equals, right? We thought that the double equals would be first. So let's go ahead and try this now. Okay, hi. The input was hi. We want exit. Is it compared to exit? False. So let's type in exit. Okay, so I've got exit. It's reading an exit correctly. Right? So what's going on here? Now, the reason that this was not working, is because of the way strings are stored and what we're doing over here. Strings are references, right? They're objects, right? I mentioned that basically we have primitives and we have objects. Okay. And the idea here is that when we create a string, when we create an integer, surely I had it. Oh, there it is. Okay. When we create something, when we say something like int x, right? When we say something like int x is equal to 5, okay, that creates a little box to put a integer in, right? So labeled int, so it says it's an int in there. We call it x, and we're going to be storing 5 in it, right? And that's how primitives are stored, right? We just store a value directly into this variable. Okay. And we can make this big enough to hold an int because we know exactly how big ints are going to be. They're going to be 4 bytes, remember? And if it was a double, it'd make it 8 bytes. But what about stuff like strings? Strings are complicated. String s is equal to hello. Okay. S string. And I can just store that in there, right? Like this. Sure. But now, like physically, I can physically write this in here, right? But now suppose, like the example I gave out in my videos, I was trying to store the entire works of William Shakespeare in this little space. I can't do that. When we create a string like this, right, we're doing 2 statements, remember. We're doing string s, which says, let's go ahead and make a space to hold a string. Okay? Let's make a space to hold this. We're going to call it S, and we know that there's a string that's going to go in this. Okay? But we don't know how big that string is going to be. It could be 1 letter, it could be 5 letters, it could be 25, it could be like 100, it could be like hundreds of thousands of characters in there, right? Don't know how big that's going to be. So if I then try to put in something that is like the entire works of William Shakespeare, that's not going to work, right? There's just not enough way to predict how much space there's going to be. So instead what we do is that we create what's called a reference to that space. We create a reference. Basically, we say that we're going to store it somewhere in memory, okay? And we're going to hold the memory location that string here. 0x, because it's a memory location, 5721, or something like that. It's going to be somewhere in some location in memory, and I can look it up pretty quickly. Basically, I store the address of where it lives in my RAM. Does that make sense? Okay? So now, if I created another string, string s is equal to, well, I store it in this memory location 5721. Now if I create a string t, and I set it equal to hello, say I set it equal to, I'm going to make this sure this works. Hello with a capital H, okay? And then I say t is equal to t dot 2 lowercase. Because if I set it equal, the computer sometimes can be clever. 2 lowercase. Okay. This will create another string over here, and it will have a different memory location in it. 0x2122 or something like that. Okay. Now, what the double equal sign does, it says, let's look at this box, double equal says, let's look at the box on the left and let's look at the box on the right. If they hold the same exact values, in other words, the memory locations, they're equal. Otherwise, they're not equal, right? For integers, this works just fine because the values are stored in those boxes, right? But the double equal says, are these actually the same objects, right? Are these the same memory locations in memory? Are these the same references? Which is something that we'll get into in a lot more detail when we talk about references and arrays, right? When we talk about arrays, this comes up. So as an end result, if it's an object, we don't want to use double equals to compare them unless we want to actually make sure, like, if s and t are actually the same variable, like if we did something like this. And in this case, they will be true. The double equal statement would be true. So instead, as a result, what we need to use is the dot equal statement. The dot equals method inside of the string. Sorry, inside of a string, so here. So instead of going, if it's not equal to exit, we'll go input dot equals. So this is how you compare strings, or really any type of anything that's not a primitive in Java. If input dot equals exit, well, now we're checking if it's equal to exit, we continue. So if not input is equal to exit. So now we run it. Hi. Can you be quiet? And now it stops because the dot equals will compare those values with each other. This is from the slides on chapter 4, right? Right. So double equals compares object by references, which we'll see. So it often gives you false even when they have the same letters. So instead, we want to use the dot equals method, which will return a Boolean. And here's a bunch of useful stuff, though. Since we can check if two strings are equals using dot equals. Every object, by the way, has a dot equals, even scanner. So you can check if two scanners are equal to each other. But here's the other stuff. You can check if two strings are equal to ignore case. Okay? You can check if a string starts with another string. So maybe if it starts with a couple of different letters you want to know. Or maybe if it ends with, the last couple of characters are this. Or contains, if it's somewhere in there. So the equals ignores case is actually kind of useful over here. Because, right, if I type in exit with a capital T, it just shouts it at me. If I do like that SpongeBob SquarePants meme or something and go exit, right, it types it out. So I have to do all lowercase. This is where we say it's case sensitive. If I want to make it case insensitive, I can go dot equals ignores case over here. And as soon as I type any variation of, change to equals ignores case. Oh, ignore case, not ignores. Run it. If I type in exit, it quits immediately. And if I type in, it quits immediately because that ignores the case sensitivity of it, right? So that's pretty useful. So random numbers. So let's see. We have random numbers, do whiles, okay, and sometimes. Let's go ahead. So I'm going to go ahead and technically I've taught you pretty much everything that's going to be on your exam. So I want to go back and start teaching you about some other stuff. Make things a bit more interesting for you. Okay, so let's go ahead and go to, this is something I haven't taught in this class before, and we're going to go into it on Monday in more detail, just to make it fun, because it helps reinforce our other tools. Let's go and look at documents, slides, supplement chapter 3, graphics, how to build graphics programs in Java. So we're going to learn the basics of graphics here. It's not something that you're going to get for homework yet, but it's something that I wanted to teach because a lot of students do request, hey, why don't we do stuff with pretty pictures, And the answer is because it's hard, and sometimes I don't know if I have time for it, but I know I have time for it this time around. Okay, so we're going to use we're going to draw graphics in Java using 3 types of objects. Okay, we're going to use something called the drawing panel, which is essentially the window on the screen. It's not part of Java. It is going to actually it's written by the authors to help obfuscate basically a bunch of the black magic that needs to happen for creating a graphical program. I'll show you what I mean. Like here, this is what I needed to set up a graphical. So I had to write a bunch of statements like this weird extends JFrame, which you have no idea what that means. In order to write something that does this, right? So here I was writing a maze for my 2168 class. And here, basically, I just had to break it up into multiple stuff, and it was basically overly complicated. It'd be overly complicated it's not too complicated, but it's more information than you need to know to do fun stuff, especially for you guys in 2168. So instead, what we're going to do is use Drawing Panel, because it allows us to get to graphics very quickly. Graphics is like a pen or a canvas that you use to draw shapes and lines on a window, and you have color objects, which basically dictate color, as you might imagine. Okay, so let's go ahead and grab the drawing. So let's go to the website, Building Java Programs. Yeah, don't need to practice it. I need just this, Building Java Programs. Supplements. So they provide this, and it's pretty useful because it allows us to skip a lot of stuff. The drawing panel, Java. So this one up here, if you've got Java 8 or higher, which you most likely do. This one here, if you've got Java 7. So we're going to download this. It's 187 kilobytes, which means it is a fairly hefty program. I'm going to just put it on my desktop temporarily. Okay, new class, and this will be in the browse. Let's go into Classroom intro code. graphics package. Okay. Finish. So first thing I'm going to do is that wherever I want to use it, in whatever project I want to use it in, I'm just going to drag it and drop it in so that we can use it, right? So I'm just going to drag it into the same over here, and it copied it over. It says I've got a bit of an, what's my error? It says, oh, right, and now I need, because I put it in a package, I need to add the package declaration to it. So, whoops, package graphics, right? There we go. And as you can see, it is quite the hefty file. It says it's about nearly 5,000 lines long, although they say that basically the important part is less than a page. Okay. But this is what we call something, a concept that we're going to learn called encapsulation, which is a fancy way of saying if it's complicated, there's actually a lot of stuff we don't need to know about it, and we can just ignore it and just focus on what it can do, not how it works. So let's first create a graphics let's start this. Let's create a drawing panel. Panel is equal to new drawing panel. So let's go ahead and run this and see what we get. Boom. We get a graphical window, just like that. Oh, it doesn't like to, it doesn't like that because it's got a title. Let's see, can I give it a different title? Nope. Needs, what does it need for an constructor? Well, obviously what I need to do then is just turn off the automatic scene switcher for right now. Stop. And use that. Great. Okay, so we've got our drawing panel up here. And it's got a nice cool thing at the bottom. It tells you what XY coordinate you're on. Okay, so as I move my mouse to the right, my X goes up, and as I move my pixel down, my Y goes up, which is a bit weird. But this is the way that basically the coordinate. So we've got a coordinate plane of pixels over here, and the way coordinate planes work in computer science, they always work like this: is that 0, 0 is that we're working not in the top right quadrant of the coordinate plane, but we're working in the bottom right quadrant of the coordinate plane, so that this pixel over here is 0, 0. The top left corner. Why? Because when we get into arrays, that makes sense. A lot of the stuff will make sense when we get into arrays. And then also it tells me the RGB values, the red, green, blue values of all these pixels over here. So next, let's go ahead and get our graphics. Panel.get graphics. Graphics G. So now, what I like about this is that it allows me in 2 lines, and I just got to import the graphics library from the abstract window toolkit. So a lot of this is unnecessary, but what this allows me to do is that in 2 lines, I'm ready to start doing some basic graphics. So G dot draw. Let's first start by basically some basic stuff. So G dot set color. So I can give it a color to change. So color dot blue. G dot draw rectangle, and this is the draw rectangle method. So basically, this line is not part of standard Java. This line, not part of standard Java either, kind of. But the rest of it is. So this allows me to shortcut to the nice stuff that looks pretty cool. So let's go ahead and do... so it says, where do I want to put... So the XY says, I want the XY coordinates of the top left corner of the rectangle. So let's say I want to put it in the corner that's 100 by 100, and then let's just make it a square. 50 pixels wide, 50 pixels, so sorry, 50 pixels high, 50 pixels wide, and run it. And it drew the outline of a rectangle, and it's in blue. So pretty easy to start that stuff. If I want to do something a bit more circular, I ask it to draw an oval. And it'll put in this. So it imagines a rectangle around this oval, right, at the top left corner. And then it puts the circle in that imaginary rectangle. We can show you by drawing both of them. Draw. Right? Imagine your graphics is a pen, right? You can either take it that it's a canvas and you're drawing stuff on it, or you can imagine that your canvas already exists and your graphics is the pen that draws stuff on there. Draw rect for rectangle. So now if we run this again, right? That's pretty cool. What if I want a different color? If I want to draw the rectangle blue, but I want to draw the oval maybe in red. You just set up color.red over there in between the statements. Right? This says change my pen to red, essentially. That's what the set color does. So it's a pretty cool way of doing stuff. Easy way. So we're going to draw. So we created our canvas, which is the panel, and then it has nothing on it. And our graphics is kind of the paintbrush or pen. So we are going to now see that basically if we wanted to fill it in, we can do something like this. Fill oval, which fills in that shape instead. Basically, instead of drawing the outline, it completely fills it up. All right. What's nice about this is that it will zoom in for us, too. So nothing too exciting here, but we can do some other stuff when we start combining it with what we already know. For int I is equal to 0, I is less than, let's say we want to draw 20 ovals. So I plus plus. Okay, and now we can say g dot fill oval. And remember, this requires the x coordinate and y coordinate of where it's going to be. And I want them to all be the same size. So I can go, so let's say I want to make them pretty small. They're going to be 20 by 20 ovals, which are really, 20 by 20 circles. So now let's start at 200, pixel 200 and 200. So this is the x coordinate right over here. And I want them, if I run this right now, all it's going to do is it's going to draw, it just drew 20 circles on top of one another. Nothing too exciting. Right? That's why I only got one. Technically, there's 20 there. They just all got drawn one on top of another. So now what can I do? Well, here, since I've got a for loop and I've got an I variable that's changing, I plus, let's go with 30. So actually not I plus 30, but I times 30. So the first one I'm going to draw at x location 200. Then when I is 0, it'll go to 230, then 260, and so on and so forth. And there's not 20 there because it'll actually go off the screen. Let's go ahead and just draw 5 of these guys. What if I want them to change in size slowly? I can do plus I. I can make them slightly longer. I'm not going to really be noticeable here. Notice they're starting to slightly elongate. If I put an I over here, they also start to elongate in the other direction. And if I multiply that I by, like, say, 10, it'll start to get really noticeable now. So what we're going to do is we're going to use graphics to review a lot of what we know on Monday. So I don't think I'm going to be posting anything for a flip lecture on Monday. Instead, I'm going to go into detail about using this, and then use this to teach some stuff about random numbers, right? So, but otherwise, so if you want to test this out and play around with graphics yourself, go to the class website. I'll also post a link to this in the announcements. But go to the to the Building Java Programs website, and you can download the drawingpanel.java for yourself and get it working. Close. Quit.